So today we are going to you're most welcome, Mr. Jovan. Hope you can hear me well. Okay.
Yes, I can hear you well. Let me try to get people in, and yeah.
Is my screen fine?
Yeah. For the most part, it looks nice.
Okay. So yes, we are here to start our session today. We are going for the Rust sessions. Maybe we could have some few minutes of sharing here and there, and at exactly 19:10 we start off the session.
Yes. Allow me to share my screen a little bit. Then, yeah.
Okay. I first allow you to share your screen.
Yes. Let me first my stuff up.
Okay, I'll stop sharing.
Okay.
We are also already live, so anyone can join in on YouTube.
Oh, YouTube is live?
Yes.
Wow. Okay. Okay. I'm struggling with my screen. I don't know why.
We are waiting on you.
Yeah, okay. I think I found my issue.
Yeah, we have 5 minutes to starting, so yeah.
Is that me?
No.
No, I don't think it.
Have you sorted it out?
Yes, I hope you can see it.
Okay, now let me stop sharing.
Okay.
Yes. Okay.
Okay. I hope you can see it now, and yeah.
Yes, you can see.
Yes. Okay. As people join in, I just want to welcome everybody to today's session. This is the first day in Polkadot, where we are going to learn how to build on Polkadot. Every moving part of Polkadot is going to be covered here. We just concluded our Solana, and yeah, we had Starknet, we had Ethereum, we had Lightning, and yeah, this is our Polkadot. Yes. So before we dive in, I want to remind you about OneRamp. OneRamp is a on-ramping service whereby it allows users to onboard to crypto using stablecoins, using CUSD, Bitcoin Lightning, and yeah, basically it has developer tools. So when you come to OneRamp.io, you can look at the developer tools. Our recent addition is the API, which is an API that developers can plug in to their applications and yeah, start using to to on-ramp their users. So you can look at the documentation, have the necessary stuff, the quote in, the quote out. And also for the users that are building for a self-checkout, for example, maybe you're building a deep link application and you don't want to have to call the APIs, you can always call the, maybe display the self-checkout page, which is the widget. And yeah, it is possible. All the features that the API has, it can be communicated properly with this. So it has all the necessary stuff with the currency. Currently we support UX and Kenya, and yeah, we also have, like I said, CUSD and Bitcoin Lightning. We are working on adding USDC for Celo. It's something that we are working on, and also we are working to bring on StackNet team to OneRAM. So, and that will also work with both the API and the self-checkout widget. Also, another project we're working on is called Shukuru, which is a mobile application that is using the one-off APIs. And yes, it's also something we're building upon on top of OneRAM. It is basically a mobile wallet that has Lightning payments, it has USDC, and the cool thing about it is that they have, like, they are gasless transactions. You don't have to have any other coin to start transacting. You don't have to have any other token. You don't have to pay for gas. You only download and start transacting using your mobile money. So it's what we are working on. Currently it's on Android. We are working to release iOS in one of the next updates. And yes, that is that. Unless Vianney, you have something. Also, these sessions are going to be recorded, and all the videos are going to be on YouTube. So if you want to go ahead and maybe go back in the background and looking for something, you can always look at Decentralcode/playlist and look for what you want. Yes, thank you. I don't know if you have anything for me, but
I think you'll find a lot of conversations in the chat. Other than that, we can start. Okay, let me share my screen. Do you want some few minutes, or should we?
Carry on. I think everything is covered.
Okay.
Yeah.
All right. So today we are going to be looking at building in the Polkadot ecosystem. We are going to start with Rust and then go to Ink in the coming week, and the other week we shall be building on Substrate. So when you look into the Polkadot ecosystem, the Rust that is in the system is core. So we are going to start from the beginning, and then make sure that at least we cover all the fundamentals that are needed for someone to have everything. So there will be no assumptions made, and I also ask you to let me know if somebody is like wants to be admitted, or sometimes I don't see it. Okay, so I'm going to mainly be using the documentation, but I'm also going to make sure that I'm quick enough. I want to cover 4 chapters, so all 3, and then starting the 4th one. So yes, that is it. I think we can start. Do you see my screen well? If you see it well, then we can start. So for this, I'm going to have a folder called I have very many things, so let me create a folder. Alright. Maybe I can call it Polkadot builds. I encourage us to have either iOS or Linux based operating systems, so that we can so that you can enjoy the journey. Otherwise Windows is somehow limited. So okay, can't not shift control, yes. So hopefully my screen is visible. Okay. So we are going to go to the folder where we ls I'm in Polkadot builds. So let's get started from there. So when you look at Rust, mainly what you have to come to Rust with is an open mind. Rust is statically typed, meaning that you must be explicit in everything you do. It makes you become deliberate in whatever you are doing. So let me say you declare a variable, you don't have to just leave it like that. You have to make sure that you know that I'm declaring an integer, things like that. For installation, I think everyone will go into the installation. I'm not going to pass through it, but after installing, you can run this command to make sure that everything is perfectly installed. So when you receive, like, I have this, then that means that you have Rust installed. Otherwise, you can go through the documentation for installations. Don't want to leave anything every other thing. So we are going to start with a hello world program. So mainly this is going to, it's just a bare bone minimum for Rust. Actually, we don't program Rust this way, but I found it like something good to start with. So you need to be intentional about like your folder structure. So because we are going to make very many folders or very many projects, it's always very good to have a sort of a folder. Okay, so command not found, because I have space, mkdir hello Rust. Okay, so cd hello Rust. This is not like the way in this example is not the conventional way to do Rust, but there is something I liked from this from like this mechanism, and one is that as long as you have a main function, you have a Rust program that has started. So so this is like, okay, let me just keep building and I explain. I think So we have so the way we start a Rust project is using cargo. Cargo new is a command for starting a new Rust project, and so we can launch our project in a VS Code. Now when you launch your project in whatever editor you see, you find out that when you start a project like this, maybe with cargo new, it doesn't just come with only the main file, which is main.rs. So Rusty's extension is called rs, so .rs, like you see .js, so but comes with this folder structure. Yeah, hopefully everything is visible. It comes with this folder structure where you have the cargo.toml. So this cargo.toml file helps you to put your packages, versions, and palettes. As we go on, we shall be looking at what palettes are. Then we have the target, where your builds are always are. Then we have the src. Now this is like where your main function main.rs stays. So yeah, this is like the folder structure of Rust. And when you run, for example, things like cargo build, you will have the executable stored in the target folder. So waiting for this to complete. You can start terminal with terminal new. I hope everything is visible. Okay, I hope everything is visible. So we are here. So when you want to build your Rust, maybe your program, you want to make an executable or a program that you can transfer here and there, or you want to build and see what are the outcomes, you run cargo build. But the cargo build command is a command that will build the entire thing. So this shows that it has been finished, because it is going to print hello world. If you want to sort of just run like in a debug format, and there is command called cargo run, and some of these commands, if I don't mention much about them, they are in the Rust book. But my aim here is to make sure that I break through the hindrances that stop people from, of course, reading the book and also understanding it. So yeah, this is cargo run. So we've seen that cargo run is kind of fast, and there are other commands like cargo check, so checks for errors and something. There is a command for building documentation and so on. So that's the way we start our project. But there's also another way that you can just have a main.rs file. I think that is this first way, hello world. So we have been at hello cargo. So for this I intend to do this programming guess. Now this chapter 2 is made in such a way that you get the feel of Rust, the feel of the flow. It is not limiting to like just learning, but you're going to see how things go along. So we are going to go into this programming guess game and see how it has been, and then maybe we can have a break. If not, we can just keep continuing. So as we said, so I have my folder called Polkadot builds. In here I have hello Rust and I have starter. So I can go back because now I want to start the guessing game. So So in the Polkadot builds, we shall maybe have other things like ink or substrate. So maybe in Hello Rust, that's where I'm going to put all my Rust projects. So if I want to start a new cargo new guess number, so wherever I want to start a new Rust project, you start with cargo new and yeah, the name of the project. So I want to go into that project file, and then I start my VS Code. Now we know that we had another VS Code running, so I think let me first stop this one so that my computer is not used up so much. Okay, so the aim of this is going to be sort of like a bootstrap through Rust. So we are going to have very many things that we are going to bring together, things that we are going to study and things that we haven't studied and those that we have looked at. So we have looked at a folder structure, cargo.toml. Cargo lock is a file that we don't tamper with because it just makes sure that it locks our dependencies to the dependency versions that we've had, so that we don't always have any issues. Target is where most of the time our executables are. src is where we have the main.rs. So when you're here, when you press Ctrl P, it can bring a search, and then when I click main.rs, it will open the main.rs. If I press Ctrl and the snake, it can also bring the terminal, but you can also use terminal, new terminals, things like that. Yeah. So okay, we could follow through. We have created, this is the cargo.toml which we have looked at.
Sorry to interrupt. Could you please zoom in?
Thank you.
Both of the browser and also VS Code.
Thank you so much for that.
Yeah, you could maybe make it full screen and then zoom in, because the editor is so small.
The VS Code.
Yeah, and also you can zoom in. Yeah, and also the browser.
Okay.
All right.
Is that okay? Or it's too much?
I think that will do.
Okay, thank you for that. So yes, some of the things we've seen. So this game is mainly a game whereby you guess a number, and if you guess it right, the game will tell you you've guessed it right. So it sort of encompasses all things that run on the stack. Anyway, we shall see in front what a stack and a heap is, but yeah, it's a good start from. So okay, we can start from here. So since we are running a guess number, guess the number, and so I can as well copy and paste here, but let me type so that I can easily explain. You'll look at this in the Rust documentation, but whenever you are going to type into something in the Rust, most of the time that variable that you type in is taken in as a string, and then later on maybe converted to an integer or any other thing. But so for this game, we are going to ask a user to type in a number they think, between 1 to 100, and if the number is right from the guess, then they will have 1. The number is not right, then they will be prompted to guess again and again. So please type your number. So now print ln is a macro, as we shall see in the future. It's a macro that displays something to the screen of the user of the program. So now when we are receiving a variable, when we are receiving some input from a program, from a user, we always use mute. So Rust has some two cases where we have mutability and immutability. For a variable to be immutable, it simply means that that variable will not shift or will not change. And for a variable to be mutable, it means that the value in that variable can be changed. Yes, we are going to keep going deeper into this. Maybe now I want to receive, for example, the user's variable in terms of a string. We can reference to mute guess. Yeah, I'll use that same thing. Is it string? Hopefully it is string. So when I complete this string, this guess is immediately turned into a string value. I think I have some extensions. I don't know, but I'll check for the extensions if I have any, that in case you program and you don't find that you have auto completion, because sometimes when you install Rust it comes with all these things. But yeah, so this is the value that the user will input will be stored in the guess. So now the next thing is to also look to start this program that can always give random numbers from maybe 1 to 100. Yes, hopefully I can. Okay, IOSTDIN line. I think the best way is it could take me time. I will first copy it. So yeah, the reason why I pasted is I think time could be running, but I'm going to explain it as we move. So I've removed that because this can also be taken in, but it has some issues. So this is like an error handling method. So IOSTDIN studio input. So this is how we receive the input, by reading the line. So we are going to read the variable and store it in the guess variable. We are going to read the input and store it in this guess variable. When you are reading this input, this one will import IOSTD. Yeah, if I try to save, yeah. And so this is going to save the guess into the guess variable, what the user's input. Then we can print. But there was something that I removed. Maybe I will explain further. So this expect is a error handling mechanism, whereby in case we fail to receive any input from the user, then this error will be displayed. Yes, you can as well put without the error, but it will show you some error because it will not have a way to handle cases where users input nothing. maybe we can first do cargo run. So on line 17, okay, there is an issue here. So these are some of the things that Rust is good at. It quickens your life during debugging. Like sometimes you can make errors that you don't even realize, but it will help you to debug. So if I save, Ctrl S, and then so you see here there is IO. A built-in type with similar exists, so stdio. So this is what I was talking about, that this IO is something that we have to import. So if I save this, I don't see any other error. Control W. Ooh. Control V. Guess the number, and I put in maybe 20. You guessed 20. So our program does not identify whether this is a string. If I guess another number, maybe I put in 34. Oh, cargo run. Please input the number 34. You've guessed the number. The program just prints the number that has been guessed. And also the other thing, when you look at this macro, one of the ways we return the value that has been presented by a user is using these curly braces or brackets. Yes, so you guessed, then curly brackets, then the variable. Okay, so talked about use stdi. So one of the things that as you continue using Rust, you'll find that Rust has many libraries, crates, and other things that you can import that have already been, for example, defined, and you're going to just maybe use some of their things. And one of those libraries is the stdi. Use std double quotes io. Then we have the main function, of course, like most of the programming languages. Yes, Rust starts with the fn main. So when you're naming your functions, you begin with fn. Some others begin with function, but this is a naming convention, and the program starts here. So you can have multiple functions, but we start from the main function. Okay. So mutable means that it can be changed. A user can put any other thing, and if you don't want to have a mutable variable, we can have something like, so let m equal to 5. As soon as I give it 5, it will name it explicitly. So the same way you can say m colon, because you have to always give the data type of that variable. So in this case, if I, for example, if I change the value of m and say m equals to 6, Rust does not allow this because the value of m is immutable, it is unchangeable. So if I want m to be 6, what I will do is I'll make m mutable. So let mute m and then have m as 6. Yes, maybe it's also at this point that I can cover shadowing. So shadowing is when you have, let me select m be given to a string. Yeah, for example, I can say m equals to 40. So this is a string, and I can shadow that variable by saying let again m equal to m maybe dot pass something. So dot pass, and I pass in that string, or I pass in something else. But we are going to say shadowing, I think, in this example, and this helps so much when you're converting variables from strings to integers. Yes, so there is mutability, there is immutability, and there is shadowing. Shadowing works in a way that you want maybe to convert from a string to an integer, so you can pass it to a string or something. But let's continue. So as we talked about, this is for receiving the user, handling potential failure. Expect is always handling failure, and you can also continue further where you can say dot match instead of expect and handle failure better. But yeah, these are concepts that you get used to whenever you're interacting with Rust. Rust has very many things, but yeah, you get used to one concept at a time, and just like that. Okay. So we are going to generating a secret number. So this is a good thing. Remember that a crate is a collection of Rust source code files. The project we've been building is a binary crate, which is an executable. The rand crate is a library crate which contains code that is intended to be used in other programs and can't be executed on its own. So yeah, this is the reason why I came up with this example is I know that it is not so beginner friendly, but then it keeps you inquisitive about the structure of Rust. So here we are going now to generate the random number, and one of the easiest ways to do it is to add rand to our dependencies, and the dependencies are always in cargo.toml. So under here dependencies, so we can add the rand. I think it is 0.8.5. Okay. So as soon as we add this crate, it will give us the capacity to utilize the functions for creating a random number easily. Okay, we don't have to add a semicolon. So we save, and then yeah, can continue. Now without changing any of the code, let's build the project. Okay, if you open the source, showing reproducible builds. So most of these are about how your code is always maintained. If for example you want to use another version of rand, but for this we are going to be using this version. and I encourage you to also keep going through that document, because just going through it, we have 4 days to cover something that is good. So let me see, cargo run. Cargo run is to make sure that we can download those files for run. Okay, please enter the number 4. We guessed 4. Okay, so we continue. So we can have this run. So for this secret number, this is one of the ways we utilize the run. And one of the questions you could be asking yourself is, how can I know, like for example, this line of code? One of the things we are going to see is you can easily check the documentation of most of these crates, but yeah, that's one of the ways you get to learn some of the way crates are being used. But also, if you hover around something, you can see retrieve the lazily initialized thread local random number generator seeded by the system, intended to be used in methods chaining style, e.g. thread rng.gen. So it gives you some sort of know-how. But so we have just declared the variable secret number with a rand, and this thread.rng is one that can be used to generate a random number. So if you want to move from 1 to 100, then your random number, you must have to use these two. So this shows that I want a random number from 1, the lower case is included and also the upper is included. So 1 is inclusive and 100 is inclusive as well. And we can print this random number as well. Maybe print ln random. Let me use just secret number the way they used it. Secret number. So syntax error, expected semicolon. Yes, this is a semicolon. Okay. Someone wants to join. I don't know why. .gen range. So no method named gen range. So we can look back through the documentation. Generate range from 1 to 100. So run thread RNG. No method name gen range for the struct thread in the current scope. Item for trait can only be used. Trait is in scope. Okay. Please enter your number. Guess string.
Sorry to interfere.
Yes.
Have you imported the run package on top?
Oh, you're right about that.
Yeah.
Okay. I don't know why my program always had that that sort of completion, auto completion. Yeah, so that's a very good thing. Whenever you introduce a new crate, you most likely are going to put it in your cargo.toml and then also import it in your main.arrays. And yeah, the error is gone. Thank you for that. Let me see if it runs. Cargo run. Could not compile guess number. Previous error. Okay. First. Okay. I think I'm making my program a bit too wordy, but yeah. So I think now I can run it. Cargo run. Yes, so guess the number. Secret number is 10. Now you can guess your number, maybe 50. Of course that has to be changed. We have to make sure that the secret number cannot be visible. I think there is someone coming in. Someone wants to join. Admit all. Okay. So yeah, so we are progressing. As we said, the essence of this program is to make sure that we kind of like go through most of the things in one program. Then we are going now to revisit each thing as we are going to other programs, and we are going to the other chapters, because they'll be all about this. So if you get lost somewhere, you can ask. If you get lost in anything, you can also comment. But mainly what we have been having, we are asking someone to guess the number. Then random number has this run.thread.rng.gen. In case you want this, there is always a documentation. There's a way you can generate the documentation. We are also going to see that for you to understand this or to come up with this. Then you can input your guess. This is what we have had. Then we are here. So you won't just know which traits to use and which methods and functions to call from a crate. So each crate has documentation with instructions for using it. Another neat feature of Cargo is that running the Cargo doc open command will build documentation provided by all your dependencies locally and open it in your browser. So yeah, this was what I was talking about. For example, if we take on cargo dock open. So this automatically creates a document, and you can come here and you read through the rand implementation. So if rand, and this can also help you to enlarge your knowledge about a given crate. You can also look into other things that have been used. So yes, that's also a very good command, and we can continue. So now we are going to compare okay. So for this you could type. I usually love typing it, and since I'm running out of time, I often, it's better if I copy it. So in Rust we have this match. Also, this is a lesson to come like in the future, but a match is one of the things that helps you to compare between two values. And for this we are going to be comparing between the secret number, which we declared up here from our rand. We know that it is of type I32, and also the guess. Now the guess is of type string, so that is already a buzzword. So we want to compare between the guess and the secret number. I know that this will not pass because they are of different types, data types. I think yeah, these are one of, so mismatch types, expected reference at string, found reference, integer. So for this now we have to make sure that we change guess to an int, because we want to compare between integers, and this is where shadowing comes in, as we had stated initially. But here we can continue. One of the things I always forget is this because I don't know why, but most of the time my IDE autocomplete, so whenever I import something it auto imports the crate from here. But this can help you in the ordering so that you remain with this error. But the good thing with Rust again is that it will automatically show that you have an error here, you have an issue here, yeah, things like that. Okay, so we are continuing. So for us to make sure that we can compare well, we have to turn this into an integer. Okay, I don't know who that is, but yeah. So we are going to discuss about this statement as we okay. So from here we have gotten the guess, even can be after here, whereby we can now change, we can shadow the guess variable into now making it a U32. We are going to read more about this, but this is a very powerful thing that I've seen in Rust. Wherever you are having a variable,
vai todo mundo tomar no meio do cu.
Could you help me mute someone?
I think you're good. She's muted.
let me just
Sorry about that.
let me just continue. Okay, so whenever you are having a variable and you want to change it, and most of the time this happens because most of what we receive from a user is always in form of a string, but to convert it into other variables, into other variable types, we use what we call shadowing. We don't use mutation. Mutation just helps you give you another value to feed the variable. So it gives you an option to feed the variable with another value of the same type. But when you want to change completely the type, this is where shadowing is. So you can rename the same guess. So this is guess. Now this is the new guess that we are having from the old guess, because the old guess is of type string. This one is of type uint, and then you trim, you pass, and the expect, as we said, is a header handling mechanism, yeah, to help us in case anything has gone wrong or somebody has not typed a number or has left the space. So immediately we bring this into play, the error disappears, and match will help you to compare between the variables. If the value is less than the secret number, then to be too small, too big, and yeah, you can first run cargo run. So let me just put in maybe probably 70. So too small, but it's good. I can see the random number. I can again do cargo run. The reason why I clear is because sometimes when I upload, some people don't sit down there, so make sure that I have cargo run. Can put in the secret number. Let me put in 85. Yeah, you win. So we have winning, too big and too small. Now I want to make sure that in case a user inputs a variable that is not winning, they are given other alternatives to input other variables. So we are going to introduce the loop. Yes, this starting session has become something big, but it helps you to really break down very many strongholds that you'll find in the future. So yeah, print ln the secret number, match. I think these are explanations. Okay, so we can put the loop. I think we have a loop here. I immediately introduce a loop. We know that a loop will loop indefinitely. Okay. If I put it here, so I want to loop up to around here. So cargo run. So you guessed nothing. Clear. So we must put in, let me say 30. So please type your number 29. So even if I win, the thing keeps on looping and looping and looping. So this is something that we don't want. Even we can put the loop around here, but this is a behavior we don't want. So we want a behavior that in case maybe I make the right guess, I'm opted out. So to opt out of such a loop, you have to press Ctrl+C. somebody is coming in. So okay, so for now, for the quit, I think we are almost done for this one. I know this guest thing is something that is so huge, but it helps you to open your mind. So if you order right, if you make a right guess, we can use the break keyword. Break helps you to stop a loop. Simple. Instead of this. So yeah, this break can help you can help you to loop out when you make a right guess. And I think we can complete this once and for all. So the other thing we can look at is handling errors. Instead of just returning this expecting message, we can handle errors differently and in a better way by using the match keyword. So could you help me with, I don't know, someone is okay, somebody is into so yeah, as we've been saying, this is a better way to handle the errors. A match also returns two sort of two return types. We have the okay and the error, and the okay is returned when we have Mr. Jovan, could you help me admit people? I don't know, can you admit?
I don't know if I have the rights to approve. I don't think I have the rights to approve.
Otherwise, it seems I'm going to leave people behind because yeah, I'm always interrupted. But okay, we are going to continue. So yeah, we've roughly looked at the guess game, and people are still coming in, so I don't know. But yeah, this guess game is sort of a high level of the entire stack based Rust. So things that don't change, data types that don't change, and this game helps you to open you up when you're going to read these other chapters. I'm going to just be going through these other chapters because we are now going to be finding most of these things in, like, having been touched in this guess game. Yeah, so this guess game is quite long, and that's the biggest reason I wanted to go through it. We can go to programming concepts. Someone has also asked to join, so I always find it an issue to to add people, but hopefully everything will be okay. Kindly provide where you'll find the recording. Okay, so you are no longer presenting. I think someone is presenting.
I think you should plug your screen, and also I'm going to share the links in chat for the videos, because I'm seeing some people requesting for them. Yeah, I'm going to plug that in chat so you guys, you can look for all those resources. Yeah.
Is my screen visible?
We do not see. I think you're sharing my screen.
Okay.
You can reshare yours.
Let me stop screen sharing and then share again. Maybe from that we can first take breaks and people ask questions, because it seems people have also many questions. Yeah, my aim was at least to reach on ownership, and but I know that guessing game takes a lot of time, and sometimes you may not get it at first time, but when you pass through it and you go through these other modules, you quickly grasp what everything meant, because we shall come back to things like shadowing, we shall come back to immutability, we go to ownership and find heaps, so we shall again be referencing to that. But yeah, we can have a Q&A. Let me also look through this. I think everything is okay. Alright, so let me just continue. Hope that's okay. So we are going to look at various. So we are going to look at variables. So variables in Rust are mainly explicit, as long as you know that if I'm naming a variable, if I want to have a string, I should explicitly make it a string. If I want to have an integer, I should explicitly make it an integer. That's all about variables. So let me just start a new thing. So cargo new variety. So we can cd to variety. Okay, so we have started our source code. I think I can close this for now. Okay, so that we have one source code, Visual Studio Code running. Hey, I don't want, I want to go into variety. cd variety. Yes, code dot. So as we've talked about variables, we are just going to be making sure that our variables are explicit. By explicit we mean, what have I typed? By explicit we mean that a variable is what you wanted it to be, you cannot, in Rust you cannot say initially start with a variable that is a string and you just want it to change to an integer and then the compiler will notice it. No, the compiler is strict enough to make sure that whatever you have named your variable to be, that's how it is. So okay, so let me say can have let x be bound to 5. So this x is of type can be of type i32 or use something. So I can say let y be bound to let me say m. So this is another character. I think besides the UC character, if I don't put it there. Okay, hopefully everything is still fine. So yeah, these are mainly this is what you have to know, that variables are always explicit. So I think we can go through it quickly. And yeah, let x print x. So let mute, so some variables are mutable. If a variable is mutable, you can change its value. We talked about that. Then we have constant variables. They take this case with underscores. So then we also have something called a scope. So in case a variable works in a scope, let me say we have this scope. So I select m equals to 2. So after that scope, I cannot use that variable here. Let me say m. Probably let me make this a mutable variable. Let mute. So m is assigned to 3. So immediately this must return an error, and the reason it is returning an error is because m has this scope. So m scope stops here. So having m here cannot find value m in the scope. So yes, you must also take care that a variable is used in the scope within which it is given. And I think we have worked on variables a bit, data types. So when you look at data types, we have string, we have integers and so on. And we have seen that this was a way of changing a data type from a string to an integer. So I think we can have that as well here, because this is one of the things that somebody is coming. Admit. So this is one of the mechanisms by which you can change a string into an integer, and most of the time you'll need to do this is it .trim.pass or it is dot trim, then dot pass or dot expect. So always expect is a quick way of error handling. It's dot pass dot expect. Okay. Dot pass dot expect. So this is the error that you that will expect an integer. So this one shows that we are going to receive a string which we shall immediately convert into an integer. And yes, so this is one of the ways. It's called shadowing, where you change a variable from the string that is received to an integer to do a lot with it. So yeah, this is easy to go through. Okay, then the other thing is you cannot add different data types. I think this was one of the things that was spoken in the previous tutorials. For example, if I have let p equal to 2 and let q be bound to 3.5, maybe if you want to have to let r be bound to p plus q, and this is not allowed in Rust because these are not of the same type. So this is a floating point, this is an integer. So yes, you have to make sure that all of them can be converted into, maybe if you give this an explicit value of an explicit type of f64, so, and you change it to, yeah, it can be 2.0 now. Let me see if I save it. Must be 2.0. So let r, okay, so now here this can be added. So that's the logic behind yes, and data types. We have also boolean. We deal with boolean in the same way. So we have also what we call our compound types, and these are tuples. So in a tuple you can have a collection. So let me, for example, the top go to 3, 4.5, 6, and probably character of I. So this can be a tuple. A tuple is where you collect values of different variable types, and you can destructure them. Destructure them is like accessing the inside values. So you can destructure them by using top dot 0, dot 1, dot 2. There's also another mechanism of destructuring. So yeah, maybe I can print this. So let me open my terminal and can go run. Okay, this is not top.0, must be in curly braces. could not compile variety being invalid due to one previous error. Expected. Okay. Okay, let me have a look where I'm going wrong. I had not noticed, but yeah, I think we are almost getting done. I don't know how that happened, but yeah. So we have looked at most of I can say the data types. I can leave us to go through functions if you have held functions in other programming languages. Comments for comments. Comments, we either use this to comment hello, or if you want to comment for documentation, we use 3 slashes. So when you save your project and you have been commenting like this, this is a tuple structure. This type of comment will be used in your documentation, and this is one also of the greatest things with Rust. You can have also multiple functions. So let's say this is your main function. You can have another function here that can return something. Maybe, for example, fn my sum, and then have something that will bring a result, and maybe you handle the result up here. Yeah, so mainly that is it. Control flow is if else, most of the same as elsewhere, but there's also some additions. So yeah, for now we can, I think, stop at that. I'm waiting if there are any questions. Next time we are going to start with ownership. I deliberately wanted to start with ownership when we come back, because ownership needs a fresh mind, and that's tomorrow. So yes, any feedback, any way you want us to do it better, or anything that you have to say, yeah, you're welcome.
All right, thank you so much. I hope you guys are caught up with where we are. Yes, Rust is an very important programming language, and I believe that's one of the reasons why a lot of these chains are using Rust. And yeah, it's very fast, and yeah. I don't know if we have any issues. Maybe you can raise them, then yeah. If that's not all, then
any issues?
hopefully we can. Yeah, so guys, remember we are going to, I think Vianney will have to share the repo where that code is going to be. Then I think the people in Telegram will have access to that, and also the tutorial is also going to be on YouTube. So yeah, if you want to go back and maybe you want to see what happened, or maybe you want to pause and watch on your time, yeah, you can always find the tutorials on YouTube. Yes, so I don't see any questions. I think everybody is good for now.
Yeah.
And yeah, so
Probably it was an overload, but I think
mm,
the pace is okay.
yeah,
Yes,
we're
because
still on program.
mm, yes,
Yeah,
we're still on the program. We have 3 more days to go for us. Good enough.
okay,
The other weeks we shall also be coming back to it. By then, things just keep growing. So yes, it's
all right.
mm,
That's nice. That's nice. So I'm waiting for the substrate personally.
mm,
I can't wait to start touching substrate.
okay.
I'm looking forward to that. Yeah. So yeah, thank you so much for taking us. Hopefully we can do this again tomorrow. And yeah, same place, same time, same link.
Okay.
Yeah.
Thank you so much.
A quick question.
Yes,
Oh, I mean, the video is being streamed live, so it's immediately available. Yeah?
the video. Yes, we are going.
This recording is immediately available. Right?
Yes, this recording will be on the Decentral Code YouTube channel. We are going to have it there. I think probably before tomorrow's session. Yes. Okay. Thank you so much. See us tomorrow. Yeah, same time, same place. As we really break, we tear this Rust thing apart, and it gets more interesting. Yeah. Thank you. Have a great time.